Hello, everyone. I'm Giulio Formenti from the Vertebrate Genome Lab at the Rockefeller University, and today I'm going to present Gfastar, genome graph tools for finishing T2T genome assembly. So the motivation behind the development of Gfastar is that to generate complete and accurate genomes, that is telomere to telomere genome assemblies, now requires extensive evaluation and very sophisticated manipulation of assembly graphs. And to this end, an efficient tool suite is actually missing. So the general idea behind Gfastar is that we have designed a set of tools in pure C++ so that we can be very efficient in our manipulations. And this tool suite allows to process files on the fly, including any FASTA file, FASTQ file, and GFA file, potentially compressed. We can generate a lot of quality control and summary statistics. That is, we can compute all key assembly and sequence metrics, N-star, GC, contig and scaffold gap counts, etc., as well as graph alignment metrics. And more importantly, maybe we can simultaneously manipulate the sequences. So we can, for instance, easily include, exclude sequences, portion of them, generate new sequences, combine them, and so forth. This is an outline of the tool suite. So we have a general purpose library, gfalibs, that handles the I/O, parallelism, file formats, and there is this interesting concept of a Swiss Army knife, the SAC, that essentially takes care of the manipulation that I was mentioning before. Then we have a set of other tools, namely gfastats, rdeval, and gfalign. So these tools allow you to process the sequences, the assemblies, but also the reads, also the alignments. So gfalign will take care of alignments, can sort alignments, can evaluate alignments, can use aligners to generate the alignments themselves, and allows graph manipulation from the alignments information. Gfastats can compute a whole suite of statistics for the assembly and also perform several manipulations. rdeval is to evaluate and pre-process the reads. So all this now constitutes Gfastar, but we plan to add more and more tools as we keep developing Gfastar. So the way Gfastar works internally is that it reads and stores any FASTA or FASTQ or GFA file in a GFA-like format. It then builds a bidirected graph representation of the assembly using adjacency lists, where each node is a segment, each arc is a gap or an edge. And then it can also read gap alignments that can be loaded on the graph. gfastats has been published this year as a standalone tool. Essentially the way it works is that we'll load the assembly. It can also load additional information in the form of bad coordinates, for instance, for pre-processing of the assembly. It then will store the assembly in a GFA-like format, can build a graph, can manipulate such graph using the Swiss Army knife, can generate statistics that can then be output as reports, or can generate new assemblies in any of the formats like FASTA or FASTQ or GFA, effectively allowing to generate a FASTA from a GFA or a GFA from a FASTA file. It's been compared to several popular tools out there like Quast, Scikit, GFA tools, and Bandage in terms of the statistics that it can generate, and essentially now it includes all the statistics of these tools and more, and it's also faster. So this is an example of the kind of manipulations that we're talking about. So this was performed in collaboration with Anton Korobeinikov, who has been recently taking over in the maintenance of Bandage NG. So this new version of Bandage to visualize assembly graphs. And here you can see the first example of assembly gaps integrated into the assembly graph. So this is a new concept. This wasn't possible before. And what gfastats does is that it allows you to load an AGP file into your assembly graph. And then here is how you can visualize it graphically. So essentially here, the red connections that you can see in the graph, these are gaps originated from some scaffolding technique that allow you then to reconstruct the chromosomes and visualize them again in bandage imaging. I mentioned other two tools, rdeval and gfalign. rdeval will compute a whole sort of statistics for reads, and gfalign will do something similar for alignments to the graph. Particularly in this case, we're using alignments from gfaligner. So you can see the number of alignments, the average read length of the aligned reads, orientation, path lengths, secondary alignments, supplementary alignments, and so forth, similar to what some tools would do, for instance. But this is not just statistics, so you can actually use this information to add evaluation to the assembly graph that was used for the alignment. So this is an example, again, in collaboration with Anton Korbennikov. We have implemented this embedded in NG so that now you can see, for instance, the support that read alignments provide to the edges of the graph, here represented as the size and the weight of the edges between the nodes. Gfastar is entirely modular, so we are planning to add new features as we speak. This has been pre-recorded, so maybe by the time you see this, there will be some of these features already implemented, but essentially we are working on indexing so that we can essentially reduce the runtime to test new hypotheses on the graph. We would like to implement k-mer-based evaluation for alignment-free statistics. We are working on making the tool in general more efficient, so having modern compilation to ease compilation with CMake, and also making it more efficient in general to reduce runtime and memory footprint. We're very open to any feature request, so please reach out to us through GitHub by opening a feature, an issue in GitHub, or just send us an email directly. With that, I would like to thank all my lab at the Rockefeller University, the Vertebrate Genome Lab, and particularly the bioinformatics team, who has actively been contributing to this endeavor. Gfastar is available in GitHub. You can see the link in the slide. And again, please feel free to request any additional feature that you may want to see implemented. We're working on a preprint so that will also be available soon to describe the tool. Thank you very much.